Okay, so the function has a parent function of x squared, but is reflected over the x-axis, has a certain vertex, goes through a certain point. We know that the only thing g can be ax squared plus bx plus c. So we could just use all these clues and figure out what g is, and that's totally valid. But instead, let's do it the way it's sort of intended, which is to use this whole idea of the parent function and reflections and so forth. And so what we're going to do is start by looking at x squared. Okay, this is x squared, and this is the x-axis, and this is the y-axis. Right? And we now say we're going to reflect over the x-axis. So this is the resulting curve. All right? And then we have a vertex of -5. So we're going to just drop that down, and then we're going to say this is the function. And it has to go through the point 3, -14. So the only thing we're allowed to change now is we're allowed to put multiplier right here in a. And this is going to be our function g. So it turns out a is just going to be 1, but I'm going to go through the motions. If you just realize that it's right, you don't have to go through these motions. But g is -14 when x here, there we go. We just now go ahead, add 5 to both sides. Then you know a is equal to 1. So g is equal to minus x squared minus 5. Great. Okay. So what have we done? Let's go back and check. We found the equation for g. Yep. We graphed g. Yep. Be sure to label the points. Yep. Got it. So, side note, when you're labeling points on the axis, you're allowed to take shortcuts. Anything on an axis. If I just put a 0 here, that means 0, 0. That's very clear, so you don't have to write the whole thing out. And this point, let's say, if I put a 4 here, it means 4, 0. And if I'm on the y-axis, same idea. If I put like 5 up here, it means 0, 5. So anytime you're on an axis, you only have to write the coordinate that's non-zero. If you're at the origin, you just put a 0. And usually you can just put a dot there. You don't even always need to put the 0. It's kind of context sensitive. Okay, so I almost forgot to go down and answer these questions. Actually, I had to re-record this because I forgot to do that. All right, so now I have to answer these yes/no questions. The function has symmetry about the y-axis. Does it? Yes. And it has symmetry about the x-axis? Nope. I can't reflect it through the x-axis. About the origin? No, because that's 180-degree rotation symmetry? Nope. Has a symmetry not listed here? No, it doesn't. Has no symmetry? Nope.